notebook right there, that white one there? Okay.
I'll get them one, yeah.
All right, I'm gonna start at 5016, 501.6. Pardon me. Positive pressure. Now what we mean here is in our vent stack, where an appliance equipped with a mechanical force draft system creates a positive pressure in the venting system, the venting system shall be designed for positive pressure applications. Okay. 5021. Vents. Okay, so our vents here are going to be listed and labeled. It says type B and BW vents are going to be tested in accordance with UL 441. Type L with 641. Category 2 and 3 appliances, UL 1738. Category 4 plastic vents shall not be required to be listed and labeled, okay? Four is what I got next. Let's see. Table, pardon me, 5034, yeah. Let's take a look at this table. I know some of you have where'd my table go? I haven't worked with well, I don't think they're going to give me a table. I don't know why. It listed the table, it just didn't show it. Okay, I'm sorry. Let's talk about this table then. Do y'all have the table there in y'all? Table 5034, table of venting system to use. We list some appliances and we list the type of venting system. Category 1 appliances. Category 1 appliances are going to use type B gas vent, okay? The type B can either be double wall or single wall or chimney. That was category 1. Now, if you remember from the definitions, category 1 had an excessive stack pressure temperature without a pressurized vent system. All right, so that's going to be our type B, single wall, chimney. Now our listed vented wall furnaces. This is different from a central furnace, like a category 1 furnace. We're going to use BW. Category 2 appliances. Like I said, as far as we know, there are no category 2 furnaces. Category 3 appliances Where you go? The manufacturer's instructions. Not here. When they buy that product, it's going to have the instructions on it. Type 4, instructions come with it. So basically they're telling us here, for the most part, category 1 is the only one we got to use the book for. Because all the special instructions are going to come with the other products. Okay? Let's look at 503411. Plastic pipe. So it looks like my number has changed here. No, okay, same number. Okay, so when we're using plastic pipe, what kind of joints? Fittings used to vent appliance shall be installed in accordance with the appliance manufacturer's instructions. Where a primer is required, it shall be of a contrasting color. So if any of you have worked with PVC or anything like that, usually we use what we call a cleaner. That's what they're talking about, the primer here. And it's got to be a different color from the glue so it'll show up for an inspector. .50354, see if this has changed. 50354, chimney termination. Let's see. 503. Chimney termination. Okay. This is getting too complicated. We'll get rid of you. Looking at that. All right. Chimneys for residential type or low heat appliances. If we remember, low heat was 1,000 degrees or less. Shall extend not less than 3 feet above the highest point where they pass through a roof or a building, and not less than 2 feet higher than any portion of a building with a horizontal distance of 10 feet. So when they come through, going to have 3 feet, this is a chimney, above the roof. And if this roof slope is such that from that vertical point, 10 feet away, it's going to need to be 2 feet above that also. Okay? That way, depending on the way the wind's blowing, it's not going to be behind the crest of the roof that blocks it. Okay? Chimneys for medium heat application, that's from 1,000 to 2,000 degrees, shall not extend less than 10 feet higher than any portion of the building within 25 feet. Chimney shall extend not less than 5 feet above the highest connected appliance draft hood, outlet, or flue collar. So, let's say you got a good roof point where you're going through, but the gas furnace, your furnace is in the attic, and it's connecting to that thing. You can't just come right out of your furnace and go up 4.5 feet. Even if that is above the roof, we still want 5 feet of draft above the last incoming appliance, okay? Let's see. Decorative shrouds shall not be installed at the termination of a factory-built chimney except where such shrouds are listed and labeled. Okay, you want to put something pretty on the top of your house, it's still going to have to be listed and labeled. You go, oh, that's an old ugly cap I got. Well, you're going to have to stick with ugly unless it's listed and labeled, okay? Okay. Looks like 6.4 is next. Okay. This starts to get, we've made some changes. This may get a little confusing. All right, 50364 is gas vent terminations, right? This is not chimney terminations. This is gas vents. We're going to use one of the following ways to vent, and they've got 7. All right, so the 2 are what we're worried about for the most part. Gas vents that are 12 inches or less and located not less than 8 feet from a vertical wall shall terminate above the roof in accordance with figure 50364. Now, so this is pretty simple. If my gas vent is 12 inches or less, y'all, that's pretty good size. You know, most 125,000 BTU furnace, or maybe even 150, is going to have a 5-inch. And so you're going to have a furnace, maybe 2, and a water heater to need over 12 inches, okay? Obviously, commercially, you might have a boiler, this and that, but for most homes, you know, 12 inches is more than sufficient. So if it's 12 inches or smaller, we're going with the first figure 50364. Now, there is an exception. You can't come out of this roof. Say you're right next door to another building and it's above you, right? It says not less than 8 feet from a vertical wall. That'll block the airflow. Can't have that. But if there's not another structure taller within 8 foot, we go with it. So let's look at that first. Figure 50364. Is that what they say here? So I'm looking at 50364. It says roof slope. Do y'all see that? You would find the slope on your roof. You see that? And then you find the height that it needs to be extending through it. Pretty simple. All right, so if I said, y'all, let's say the slope is 12 by 12, how high would you go above it to terminate? 5 feet, right? Okay, say it's 12 by 12, and let's say it's at least 12 by 12, maybe a little over. I guess that's the way the word's on here, right? Because it says to it, and then it says over. So 4 foot, if it's exact, if it's a little over it, you're going to go to 5 foot, right? Okay. Let's go back to the kicker here. Item 2. Gas vents that are over 12 inches, or they had that 8 foot exclusion broken, right? So they may be less than 12, but they're closer than 8 feet. If we do that, they're just going to flat out tell us they shall not terminate less than 2 feet above the highest point where they pass through the roof. So flat out, there's one rule. Wherever they come through, they got to at least be 2 foot above that. And if there is a wall that they pass through that's less than above any portion of a building within 10 feet, they're going to be 2 feet above that place. Okay? It's a little confusing, I know. Right? So the first thing you got to ask yourself is, what size is my vent? If it's 12 inches or less, and there's no obstruction within 8 foot, use the figure table. If there's an obstruction within 8 feet, I use this rule. I'm going to go to that obstruction, and I got to exit 2 feet above that. Let's just say it's a 15 inch, and there's nothing else up there. I got to go within 2 foot more than wherever it passes through the roof. Okay? All right.
Which one is, we're talking about gas vent and chimney termination. Does chimney termination 503.54 apply to furnaces?
If you're using it depends on what you're using to vent. If you're using the chimney to vent, then you're going to go to the chimney termination rule.
Okay. But if you're just using the gas
vent, yeah. Most people are going to use a gas vent. If you got an existing house, chances are they're going to say, I'm not going to let you cut a hole in my roof. You don't look like a roofer to me. And you're going to go, I'll go with the chimney. All right. Let's go to 50365 if we still got it. All right, now this is under the discretion of caps 12 inches or less, but they're within the distance from a vertical wall, right? Y'all see that? 50364 states that. Let's look at our minimum height for a type B or an L. Not less than 5 feet in vertical height above the highest connected appliance draft hood. And I see a type BW, not less than 12 feet in vertical height above the bottom of the wall furnace. All right, because we're only going to use wall furnaces for the BW. This is pretty similar to the other. I said we had a 5-foot exclusion wherever the furnace entered. All right, so if ours is 12 inches or less, the chances are it is, we're going to have a 5-foot exclusion for B or L, which is probably what we're running. Let's look at the terminations, 50366. These shall extend through the roof flashing, the roof jack or thimble, and terminated with a listed cap or listed roof assembly. I don't know if any of y'all have run any kind of double single wall through the roofs. Well, what you do is, the key here is really getting there way before the roofers do, because you don't want to get back on that roof. But you're going to cut a hole. Say this is your roof. So you cut you a hole here, right? And you're going to go up through this thing, right? I'm drawing something pretty good, I know. That thing is going to require a roof jack, which they make in two. They make a steep and a, I guess a not steep. What would you call that? Yeah, I guess. And so it looks like this. It's square, and it kind of goes up like a funnel. And so yours goes through this. That's your jack. Then you have a collar. So you got your pipe still sticking through here. You've got a little collar that fits down, and it sits over that jack. It's really tight to and it protects the jack. And then, of course, you're going to have some listed labeled cap to protect the rain. Okay. Mine has some pictures, but I don't think this thing doesn't. Let's look at 503.692. All right, so this is under Category 1 appliances, right? That's what most people are putting in still, Category 1s, I guess. That and Category 3s. If I look at vent offsets, that means I don't get to take the vent straight up through the house. It's very rare we get to do that, you know. Depends on where the furnace sits. Most customers on an expensive home don't want a metal vent stack sticking out in the front of their roof. They want it on the back side. They want to hide it. So you're going to have to go, instead of just straight up, you're going to have to offset. So let's look at the rules for offsets. Type B and L, okay, that we sized with item 2 or 3 of section 506.9 shall extend in generally a vertical direction with offsets not exceeding 45 degrees, okay, except that a vent system having not more than one 60-degree offset shall be permitted. Now, any angle greater than 45 degrees from vertical is considered horizontal. The total horizontal distance of a vent plus the horizontal vent connector serving the draft hood equipment appliance shall not be greater than 75% of the vertical height of the vent. Okay, a bunch of googly But what we mean here is when you look at your charts, which we'll look at in a minute, they'll tell us how much lateral we can have, how much horizontal run. That is decreased by how many 45s and 90s you have to put in there. Okay? But the rule here, the main rule coming through here is, shall not be greater than 75% of the vertical height. Okay? And this includes, it says, horizontal vent connectors. So if you're in the car garage and your furnace is here and you got a vent connector to the gas water heater, that's going to add up to the vent connector. All right. Category 2, 3, and 4 appliances. You're going to use the manufacturer's instructions, right? Which are pretty simple, straightforward. Okay. Much so for than this. So where are we at now? 503. 93. So 503, 610, 2. Let's take a look at that. Sizing. Now we're down to it. The sizing of connectors and common segments for multi-story venting system for appliances listed for use with Type B double wall vents are in Table 5043. All right. So there's your instructions. Let's look at Table 50431 for a second. I hope I got it. It takes a while to get there. Now, we're just going to look at it for a second, and we'll go back. It's basically what the whole chapter is about. Give it to you again. It's 50421. 504. Well, in my year, and that, I'm looking at 12 right this second. There we go. 50421 and the 15. Everybody see it? All right, so did everybody find the table? It's 504. It's a good way forward.
Yeah, in 15 was on page 103.
Did everybody find it? I was trying to give everybody time. Yeah. All right, so I'm looking at the first one, and this is one of many. Type B double wall gas vent. It says how many appliances? Single. What type of appliance? Category 1. What kind of connector am I making here? Am I sizing here? I'm connecting it directly to a vent. Okay. You say, well, how high is it from this appliance to my vent? And you see this, we've got 6, 8, 10, 15, 20. We can go to another table and get more, 30, 50, 100. Okay. Then you say, how much lateral feet do I have to get over there? Let's say my appliance is 9 feet vertical to my connector, and it's going to take me 5 foot lateral run. All right, so what you do is you go down to, I said 9 feet, so 8 won't carry it. We have to penalize ourselves to be conservative, so we go to 10. You can't ever, you can come back, but you can't go over what you need. All right, 5 foot lateral run. Now, you got to ask yourself, what is my appliance? Does it have a fan to help with the draft, or is it natural draft, okay? Let's say this is and all we care about is input, not output. Let's say this is an 80,000 BTU furnace. 80,000. So, and let's say it is a natural draft. So under the 10 height, under the 5 lateral, I want to go to these numbers under natural, exceed, what did I say, 80? 77. All right, I'm seeing 124 under 5-inch natural. Y'all see that? And so I could handle up to 124,000 input with 5-inch. 4-inch won't carry me at this rate. Okay? 4-inch would only do, if I can find my spot again. Thank you. So we could almost carry it, but we're supposed to move up since it was under what we're carrying, okay? So that's how this would be used. Now, let me just say, right, this is a Category 1 furnace. All these charts are for Category 1 furnaces. What if you get a Category 3 or a Category 4? There you go. This film I'm going to show you. If it's Category 3 or 4, follow the instructions. They still say Category 1, so we still got to do this on the test, okay?
Okay, what about 2?
There's none in existence that we know of.
Well, there's no Category 2 appliances.
As far as we know, they're not. We break our 4 categories are like this. They either have a fan assist or they don't. So 2 of them, 3 and 4 have fan assist, right? 1 and 2 don't have. They're natural draft. Now, what's the difference between those 2 subsets? Some have such a low temperature that the condensation, the moisture in them, condensates. Some of them are so high, like your Category 1, that moisture goes right out with the gas. And so Category 4, the high efficiencies, we use PVC because it's not hot, but the temperature does condensate. And so if we used metal, it would rust it out. And so Category 2 is, first of all, it's no fan, but it's that it won't carry its condensation out. And so nobody's invented those yet. But there's a place for them to be invented. Okay, so they're just like Category 4, except for they're natural draft, and nobody, at least that's what they tell us in the code. No one has asked for a patent on one or anything. All right? Let's see this film. I think this is very old, but it shows you how to use these tables, okay? See if I can find this film. I know y'all like the music. All right, let's see. You don't want to eject. Oh, I guess I got to cut the power on. Aha! Nobody uses this too much when it hadn't, still in it from when I taught it a year ago, I guess. It wasn't that long ago. Oh, stop and play.
You might want to get that converted to DVD.
They probably send us one if we ask for it, you know, because it's like one of those governmental agencies.
That's what, just the UPD.
Yeah, but it locks up. It says, okay, there's a patent on this machine. That's what we got the thing. We were going to convert all our VHS, VCR. Yeah. Well, it lets some of them, some of the real old ones. So we'll backtrack, but I want to show you this. It's not too long.
I need to have some software that would beat the encryption.
Oh, I'm sure, but you're talking way above my head. Let's see if I can change this here. Yeah, I don't know what I'm doing there.
Source for many years. In heating appliances such as furnaces, boilers, and water heaters, gas offers comfort and reliability at very low cost. In recent years, there have been a number of changes in gas-fired heating systems. Gas appliances have become more efficient. Prior to 1992, a conventional gas-fired atmospheric furnace or boiler had an annual fuel utilization efficiency, or AFUE, of 60 to 75%. The National Appliance Energy Conservation Act requires all new central furnaces and boilers to have a minimum AFUE of 78%. Mid-efficiency appliances have AFUEs ranging from 78 to 83%, while high-efficiency condensing appliances have AFUEs in excess of 90%. The exhaust gases from these new mid-efficiency furnaces are at a considerably higher dew point temperature than from less efficient atmospheric furnaces. This has made it necessary to change the way the venting system is sized. This video presentation will describe the changes and show an example of the new tables for designing appliance vent systems. First, let's take a look at the differences between conventional furnaces and higher efficiency models. In a conventional furnace, the combustion gases travel through a heat exchanger, a draft hood, a vent connector, and out through the vent. The draft hood is located at the point the combustion gases enter the vent connector. Its purpose is to separate the furnace from the vent, so wind effects or too much draft will not affect the burner flame. It also allows additional air, called dilution air, to enter the vent. Dilution air mixes with the exhaust gases and reduces the moisture level or humidity in the gases. Furnace exhaust gases contain a large amount of water. For example, a 100,000 BTU per hour appliance operating continuously will produce over 1 gallon of water per hour. The water is present as water vapor, but if the temperature is low enough, the vapor will condense into a liquid. When a furnace begins operating, the vent is cold and condensation may take place inside the vent and furnace. This is similar to what happens when moisture condenses out of the air on a humid day onto a glass containing a cold drink. The moisture from the furnace exhaust gases is often corrosive and can lead to deterioration of the venting system and furnace components. As the vent warms up, the moisture will evaporate and there will be no further condensation on the warm surfaces. To improve furnace efficiency, some manufacturers now use a more efficient heat exchanger and fan-assisted combustion, which eliminates the need for a draft hood. The result is increased efficiency and lower heating costs. But because of the combined effects of higher dew point temperatures and less dilution air, there is also an increased tendency for moisture to condense onto the surface of a vent. It is important to minimize or avoid condensation through proper design of the venting system to ensure rapid warming and re-evaporation of moisture. Because of the different venting requirements for the many new products now available, all furnaces and boilers have been placed in one of 4 categories, according to their operating characteristics. The category is marked on a rating plate located on the appliance. All draft hood equipped appliances and most mid-efficiency fan-assisted furnaces are in Category 1. Very few furnaces manufactured today are in Category 2 or 3. Virtually all high-efficiency condensing-type furnaces are in Category 4. All Category 2, 3, and 4 furnaces include specific installation instructions from the manufacturer, which have been tested and certified by independent laboratories. Refer to these manufacturers' instructions for proper installation. This video discusses the new vent sizing tables that have been developed for the proper installation of vents on Category 1 fan-assisted appliances. To assist in selecting the proper diameter vent system for an appliance, vent sizing tables were developed in the 1950s, which became part of the National Fuel Gas Code. A portion of these tables is shown here. It is titled, Capacity of Type B Double Wall Vents with Type B Double Wall Connectors, serving the single appliance. The total vertical height of the vent and the total lateral length of the vent connector is first located in the left-hand column. The appliance input rate in thousands of BTU per hour is then located in the table, which leads to the selection of the proper diameter for the entire vent system. Field experience over many years has shown that these tables work very well with draft hood equipped appliances. However, these tables are not suitable for fan-assisted appliances because they may result in oversized vents, which could lead to corrosion problems. To take into account the differences between draft hood equipped and fan-assisted equipment, Gas Research Institute has sponsored research to develop new vent sizing tables. These tables have been created with the aid of a computer program named Vent2, which calculates the proper vent size for the wide variety of conditions encountered in furnace installations. The new venting tables apply to interior vents and chimneys. For exterior vents or chimneys, the local gas utility, appliance manufacturer, or local code authority should be consulted. In the old tables, there was a single column of appliance input ratings that each vent diameter could handle. The new tables include 3 columns for each vent diameter. They are labeled Fan Min, Fan Max, and Nat Max. To use the new tables, first determine whether the appliance is draft hood equipped. For draft hood equipped appliances, the maximum appliance input ratings are found in the column labeled Nat Max. These input ratings are the same as those found in the former vent sizing tables. They are the maximum input ratings in thousands of BTU per hour that can be handled by the vent diameter listed at the top of the table. If the appliance is fan-assisted, the columns labeled Fan Min and Fan Max must be used. The total vertical rise of the vent system and the total lateral length of the vent connector must first be determined as before with the draft hood appliance installation. In this case, however, the appliance input must fall between the minimum and maximum permissible as listed in the Fan Min and Fan Max columns to select the proper vent diameter. The values in the Fan Min column are the minimum acceptable heat input for a given diameter vent to prevent excessive condensation, while the Fan Max column lists the maximum acceptable heat input for that diameter to prevent positive vent pressure. By using these new tables, a vent diameter will be selected that will be large enough to handle the volume of exhaust gases, but not too large to prevent proper warm-up. If the vent does not warm up sufficiently, the moisture that may have condensed on the inside surface will not evaporate, leading to a greater likelihood of corrosion occurring. The new vent sizing tables can also be used to size common vent systems, that is, vent systems that use a single vent for more than one appliance, such as a furnace and a water heater. Designing a common vent system requires 2 steps. First, the individual vent connector is sized for each appliance separately. Next, the common vent which carries the flue gases from both appliances is determined with a table made up especially for that purpose. The table for the common vent also has 3 columns for each vent diameter. The column nat plus nat is to be used when both appliances have draft hoods. The column labeled fan plus nat is for use with a combination of fan-assisted and draft hood-equipped appliances. For example, use this column for a fan-assisted furnace common vented with a conventional water heater. The fan plus fan column is for cases where both appliances are fan-assisted. By using the new vent sizing tables, vent systems can be correctly designed to handle all Category 1 mid-efficiency appliances that are currently being marketed. The new vent sizing tables also cover interior masonry chimneys. Existing chimneys should be inspected and brought up to code requirements as a part of an appliance retrofit. For interior chimneys, venting of single or multiple fan-assisted appliances is generally not recommended without relining. However, common venting fan-assisted appliances with draft hood-equipped appliances is permitted in many cases. If the vent system includes an exterior masonry chimney, relining may be necessary. Consult the appliance manufacturer's installation instructions, the local building code official, or a gas utility for specific requirements. This presentation is meant to make you aware of the new tables for sizing vent systems. Instructions for their proper use are available from many sources. Consult the 1992 National Fuel Gas Code, local building codes, the Gas Appliance Manufacturers Association venting tables, the Appliance Manufacturer's installation instructions, vent manufacturers, the local gas utility, or the American Gas Association. Good.
Okay, I think y'all got the gist of it. All right, so let's take a look at the codes. Pardon me, these tables a little bit more now. All right, so I'm looking here at 50421, and I think we kind of explained how to use that. Now, let me say this too. If you come up with a size, let's say we looked up something and said, hey, you can vent it with a 3-inch vent. And you unpack your unit and it's got a 4-inch vent, you can't go back down. Just because they said they could have vented that many BTUs with the chart, you're never going to go down from what you have on your piece of equipment, okay? All right, so I'm going to move on forward here to the next chart or so, if I can. All right. And notice, this one we were getting more and more vertical feet, same chart, but it only went up to 9. Now we start over with less vertical feet, but bigger and bigger vent. Okay, so a lot of these are continued, right? All right, now let's, if you would, find 50422. And the difference here is we're using a single wall metal connector, whereas on the other, we were connected directly to the vent. Y'all, okay?
Does that mean 2 appliances?
No, but to get there, that's what we're using, okay? We're connected to another single wall. All right. We use it the same, min max, nat, the size, the vertical height, the lateral height. All right, here we go to see 50423, a masonry chimney, 1 appliance. It's a category 1. We are using a type B double wall connecting us to a masonry chimney. Y'all, I don't know why I'm using that word. Class, when it says NA, just can't do it in that size. Cannot do it in that size, okay? You'd have to move up. All right. Continue on. Okay, type B asbestos chimney vent. exterior masonry. I think y'all heard him speak about that. You know, some of y'all are not experienced on older homes, but typically when you see a chimney that's located on the exterior of the house, it was a fireplace. Whereas you may not even know that there's a interior chimney somewhere because it's behind sheetrock and plaster and it's framed into the house, and it was used to carry some kind of draft out. Okay, so that there is some difference. But from this thing back in '92, you can see. I didn't cut that off, did I? You can see that they have put it into the code book now. All right, now let's see. Go to 50431. All right, so this is what most students worry about for the test. It is a tiny bit more complicated. Remember now, if I have two appliances, I use the single ones, the ones we just went through to size. All right, from this furnace to the connector, that's what I use. And from this hot water heater to the connector. But here we're going, okay, take, in this case, the one we're venting two appliances out of or more is, in this case, type B double wall. So it says two or more appliances. Those appliances still have to be category 1. And what we're connecting with is type B double wall connector. Now, we still have the vent height, we have the connector rise, and we still have the fan min max and the natural max, right? Let's see.
I think I have this in the 2009 copy.
You don't, what do I got here? I got 12, I think.
I've got 50432 and 50426.
Does anybody else have 9? Let's see. In 12, my first one in 12 was 50431. Same number as this one. Just, okay, if you're looking at the table, go back to your last table and see how many number of appliances does it say. The very first box at the top. Keep going then. And you may skip some pages with no tables.
Two or more. Okay. It was
Okay, so here is how I would size my two appliances, and then under it says common vent capacity, right? And here's, like he kind of talked about, what's my vertical height? Is it fan? Is it fan natural? Is it nat? And you'd find the common size, right? We had a guy who came by yesterday and asked Brian down in Montevallo, they were going to twin 250,000 BTU furnaces. They wanted to vent it together for one penetration. And so Brian looked it up. That's 300,000, right? He said he didn't know if it was 15 feet or 20 feet. And so first, Brian said, well, let's look at 20 feet. And what he got up to? 70, let's see. 300,000. They're both going to be fan. So if it's 20 feet, he'd have to use a 6-inch, right? Y'all see that? That would handle 314,000 BTUs. If it were 5 inches, wouldn't. But now, if it was a 15-inch rise to the ceiling, he'd have to move up to 7 inch before we cover 300, okay? You gotta exceed it. Now, these numbers are giving us, right? It's like 83, that means it'll handle 83,000 BTUs, right? When we go back now, let's go back to where we started on, I think the last thing we said was 503.610.2 sizing. So when we go back to this, when they talk about a 45 or this or that, that's the capacity it takes back. If the chart says, oh, it'll handle 100,000 BTUs, and this thing says, hey, you have to reduce by 15%, then that size would only handle 85,000 now, and you're going to have to go to a size that will handle that 15% or whatever the penalty is. Okay? Let's see. Whoa, stop. Where was 503.610? Look at a few of these provisions. All right, so let's take a look at this again. All right, type B, double wall gas vents according with 504 provided that. Okay, we got three provisions. The available total height for each segment of multi-story venting system is the vertical distance between the level of the highest draft hood outlet or flue collar on that floor and the center line of the next highest interconnecting T. The size of the connector for a segment is determined by the appliance input rating, pardon me, and available connector rise shall not be smaller. That's what I was just telling you. We're not going to put one in smaller than the appliance has. The size of the common vertical segment and the interconnecting T at the base of that segment shall be based on the total appliance input rating entering that segment at its available total height. Okay. What do we need to do? All right. What if 503.7? What if it's single wall metal pipe, right? It says we're going to use 7.1 through 7.13. Let's take a look at that. Single wall is going to have to be that thick. What, 0.0304 of an inch thick? What about its termination? It's going to at least 5 feet in vertical height above the highest connected appliance draft hood. Okay. See, roof penetration, 503.75. Through roof without interruption to the flash in the jack of the thimble. Okay, when a single wall metal pipe passes through a roof constructed of combustible material, a non-combustible, non-ventilating thimble shall be used at the point of passage. So, a thimble shall extend not less than 18. Okay, so that's what we have here. That's what our fire stop. So if we go through a floor or a ceiling with single metal wall pipe, you're going to have to cut a bigger hole and either buy a fire stop, or we usually don't do that, it's too expensive. You buy you some sheet metal, you put the sheet metal, and you cut out the hole the size of the pipe. So it's non-combustible. Does that make sense? And most single wall pipe has a 6-inch combustible rating, so you're going to make it at least, I'd say, 7. You don't want an inspector going like, well, this is 5 7/8. Redo this. So you're going to make it over 6 on something like that, or whatever we're dealing with. Okay? Same way here. The instructions for going through a wall, a combustible wall. Now clearances, we talked about that clearance reduction table at the end of last chapter. 503.10.5, let's see, clearance from a single wall metal pipe shall be permitted to be reduced as it's laid out in that table, 3082. Okay. Let's see. The sizing is going to be approved with the table 504. Okay, let's see, anything in here important? I'm looking for penetration. Did I already pass all that? I think I did. Well, I didn't mean that. Let's see.
Same wall penetration.
Let me read you this. 503.610, this has changed. Gas vents shall be supported and spaced in accordance with the manufacturer installation instructions. Okay. Let's see, let me read this to you, the commentary. Type B vents must be supported to prevent the weight of the system from bearing on appliances and vent fittings. Fittings such as adjustable elbows are not designed to carry the weight of upper or lower sections of the vent pipe, nor are appliance draft hoods and flue collars. Support bases, brackets, and spaces used to support the weight of the vent maintained in clearance to combustion. On most job sites, the vent shall be supported by various fields, constructed brackets and straps made of sheet metal scraps, duct slips, drives, plumbers' perforated straps. The installation shall be carefully examined to determine that such field constructed supports are adequate. Sheet metal screws must not penetrate the inner lining of any type B. You know, type B has two. It's double wall. That's why we call it double wall. You can penetrate the outside for support, not the inside. Type B vents are designed for installation without the use of any additional fasteners that penetrate the vent wall. So if you had messed with vent type B pipe, it is a pain, and it's also very expensive. But anyway, each brand works with itself. There's a lower and an upper. You can't go. It's not interchangeable. There's a male and a female, and they lock into each other. That's what I mean. They support. A 5-inch or a 6-inch 90-degree elbow, adjustable, is double wall. It's probably over $20. And so if you got to price that in, you go, well, I can buy a furnace cheaper. If there's not a flue there, if you put it in there, that's expensive too. Okay. All right. Let's continue on. Let's. Do we have a 7.4 limitations of use? 503.7.4. Single wall metal pipe shall be used only for runs directly from the space in which the appliance is located through the roof or exterior wall to the outdoor atmosphere. That's pretty much the whole run, isn't it? Okay. Let's look at table 503.10.4 there. Minimum thickness for my galvanized steel vent connectors for low heat appliance. So you know, this is relatively unimportant. You're going to buy the connector, but on an exam, they're going to say, what's the thickness required? So here's where you come on your vent connectors. And this is going to be based on how big the pipe is. Less than 6 inches, 6 to 10, 10 to 12, 14 to 6, over 16, you see the minimum thickness, and I guess this is down to 1/1000th of an inch. We have another table for medium heat. That'd be from 2 to 3,000. Okay. All right, what about joints? Okay, see my slope here? A vent connector, 503.10.7, I'm sorry. A vent connector shall be installed without dips or sags and shall slope upward toward the vent or chimney not less than 1/4 inch per foot. 1/4 inch per foot, right? All right. Let's look at my length of my vent connector, 503.10.8. The maximum horizontal length of a single wall connector shall be 75% of the height of the chimney or vent, except for if it's especially engineered. The maximum horizontal length of a type B double wall shall be 100% the height of the chimney or vent for engineered systems. Okay. All right, we're going to 5.4 now. 2.2. All right, 504.22 minimum size. When the vent size determined from the tables is smaller than the appliance strap to it, the smaller size shall be permitted to be used, provided that all the following requirements are met. You're not going to do it. All right, let's look at vent offsets, 504.23. Single appliance venting configurations with 0 lateral links in the tables, those are the tables we just looked at, shall not have elbows in the venting system. Not allowed, but we know that that's very unlikely. So single appliance venting configuration with lateral links include 2 90-degree elbows. Okay. For each additional elbow up to 45 degrees, the maximum capacity listed in the tables shall be reduced by 5%. Each additional elbow greater than 45 up to 90 degrees be reduced by 10%. All right. What else we got? Look at this 504.38. 504.38. It says the cross-sectional area of the common vent, when we're putting two together, shall be equal to or greater than the cross-sectional area of the largest vent connector. So you're never going to take two. Say you've got a real mix match. You got something, we'll say a 6-inch, some big appliance, and maybe a 3-inch. And if the table spits it out, hey, you can get by with a 5. This rule overrules that. It says, no, you can't get smaller than the biggest of the two. Okay? All right, let's look at the next chapter. I didn't have anything written down here, but we've definitely got some test questions here lately out of this. So, specific appliances here. This is where you want to come if you're on the exam and they ask about a particular thing, like say a floor heater or a wall furnace, or instead of just something, a central appliance. That's chapter 3 or 4. But if they got some, some kind of gas log or something, okay? So let's take a look at this. I'm just going to kind of jump through these. It's a lot of stuff I've never dealt with. Any questions on floor furnaces? You see, I'm right here on 609. We got a whole thing on, see, bracing, clearance. Duct furnaces, that's something you don't see a lot anymore, where you had an air conditioning system, so they added a duct furnace for heat later on. You just don't, very rare. Non-circulating direct-fired industrial air heaters, okay. Recirculating direct-fired industrial air heaters. Clothes dryers. Sauna heaters. Pool and spa heaters. Some of this stuff's not for us. It would be for the electrician, I'm sure. And, I'll take that back. If you're piping in the gas, you're going to be on top of it. All right, how many of you have seen a gas-powered refrigerator? Not many, but they're out there.
I got one in my campers.
Yeah. If you've got a cabin somewhere or something and there's no electricity, although nowadays you'd probably be just as easy to buy a generator than it would to drive gas back and forth for propane. But anyway, gas-fired toilets, gas run air conditioners. All right, so I'm not pointing anything out. I'm just saying if you get a question on anything specific, go there. Okay, so let's look at our Appendix A then. This is the sizing of our pipe. We said we're going to run through this, and it's a lot easier than you think. See, Mr. Brown make it. Kerry Edwards, see you slip in here. I see you back there now. Marcus, Nancy, Rob, Shane, Kendrick Reeves. All right, I'm here in the instructions, and it says, to determine the size of piping using a gas piping system, the following factors must be considered: available loss from the point of delivery to the unit, what our maximum gas demand, the length of the pipe, specific gravity of the gas, and diversity factor. And so, this sounds kind of complicated, but it's really not. First thing they're going to show us here, we'll do a problem in a second, is table A22, equivalent lengths of pipes and fittings. And although we might want to look at a rule here to establish the rules. I take it back up to right before that, appendix 2.2. Did we get to that? Low pressure natural gas fittings. All right, I'm not going to read you that, but I'm going to read you the last sentence. Okay, it says, in using these tables, yes, I showed y'all earlier on there was a math algebraic equation to solve it. You know, I don't know anybody who does that. They use these tables, okay, that we saw earlier. You know, but anyway, if you're going to use these tables, keep this in mind. An allowance as far as length should be considered for any piping run with 4 or more fittings. Well, who puts in a piping system that doesn't have any fittings? No 90s, no unions, no cutoffs? Okay, you know, you're drinking. So for those fittings, if you've got 3, just use the table. But if you've got 4 or more, use these fittings to add to it. So if you say, well, I got 100 foot. No, if you've got 100 foot and 4 footings, we need to add a little bit for that. So let's look at that. My table 2.2. Look at these fittings. I've got screw fittings and welded fittings. Okay, so I know it may be more likely that you're using maybe black iron or something. That's a screw fitting. But, you know, if you're doing it commercially, you may very well have some welded fittings. So you would find them. Look at this screw fitting. I have a 45 and I have a 90 degree, and it says L will be the equivalent length. So for every one of those, let's say a 1 inch, 90 degree elbow, I'm going to add 2.62 feet to my total length. Does that make sense? And I'm going to be honest with you, if I'm laying this out, if I'm doing somebody's gas pipe, I'm going to be way conservative. If I think it's got 70 feet, I'm probably going to say 80 feet or something like that, okay? I'm going to err on the side of caution. And so anyway, we got fittings here. We got more fittings. I got T's here. Did I have T's up there? So those are just welded T's. Here I've got valves, you know, gate valves, globe valves, angle valves that are screwed in. All right. Now another little footnote, I think. So by the way, if you get a question, we think they've dropped it. When they say, what is the equivalent length of such and such with this fitting? This is where you come to this table in the appendix. Okay. Take a look at table A24. A24. And I'm going to read you this little thing before we look at it. It says, natural gas specific gravity. Gas piping systems that are to be supplied with gas of a specific gravity of 0.70 or less can be sized directly from this table. So, you know, some gas is good, some of it's pretty bad. But they're saying 0.7 or less, you can use the table. However, if it's greater than 70, we're going to use this multiplier. So let's look at it. Let's say, looking at the table, that you had a specific gravity of 0.75. I would find 0.75 and find the multiplier 0.90. Do y'all see that? So that means when I'm using this table, and it says, hey, this size pipe with all these configurations can handle, it's not going to say in thousands, it's going to, you have to multiply by thousands, but it's like, oh, it'll handle 80,000 BTUs. You'd have to multiply that by this multiplier. Does that make sense? because your gas is that bad. Okay? And you see it goes way on down. 0.6 is dead on the table, but they don't make us worry about it until it gets really bad. Okay? I mean, I've never called Allegasco. I don't know what ours is, but it's apparently pretty good. We don't have a whole lot of other stuff floating in our gas, not terribly where the gravity's bad. Okay. Let's look. Okay. The longest link method is what we usually just go over. There's branch method, there's a couple hybrid, but this pretty much explains it. The longest length method. Okay. So let's go to it. Where's my example for the longest length? All right, I think mine says example A6, 1, example, longest length method. Is that what y'all have too? We'll just show you how easy this is. All right. Determine the required pipe size of each section and outlet. With a designated pressure drop of 0.5 inches, water column, using the longest length method. The gas to be used has a specific gravity of 0.60 and a heating value of 1,000 BTUs per foot. So let's take a look at this. So I've got a pressure drop, 0.5 inch. Is that 0.5? No. 0.5 inches of water column. Specific gravity. 0.60, with a value of 1,000 BTUs per cubic foot. All right. Now, let's see what they showed. I have a point of delivery. That's where the meter would be outside. They hang my meter and I get my gas. I have a section that runs 10 feet. I have a corner that runs 20, and we're going to call that section 3. Okay? Then I have a T up here that runs 2 outlets. Let's see. Outlet C, outlet D, and we're going to consider that 20 foot, and it's section 2. Now here I'm going to go 10 foot. This is going to be section 1. Beyond it, I have a 15 foot run to outlet B. A 15 foot run and a 5 foot run to outlet A. Maybe they mean this entire thing is section 1, I don't know. Now at A, I got 35 grand. Clothes dryer. B, whoa, I got a big old stove, 75. At C, water heater. At D, got my furnace. And that's it. So we need, hey Brian, let's see you back there. You need to talk to me?
I didn't know if you were recording.
I am. You want me to pause it?
These things,
Y'all, give me just a second. You know. Oh, y'all solve the problem and I'll be back. All right, so our first step here is we want to, I gotta know what my total demand is. Okay. Okay, so let's see. I'll make me a little table here. A is 35. B 75. C is 35 again. D is 100. I'm doing this right. 5, 10, 15, 10, 11, 12, 13, 14. Is that what everybody got? 245? Let's see what they say. And their answers. Alright, so now I don't think they told us, or if they did, I didn't announce it. What are we making this thing of? That's probably the hardest question you're going to get is, this copper line, and in residential, that's about all we make them out of is type L copper. But let's see. They say, I don't think they say in my example what they want us to use. They may just have emerged. But they want us to use table 402 2. So that'll tell us what time we got. When I go to 4022, is that schedule 40? .402.1 is schedule 40. 4022 is schedule 42. Oh, okay. So now why did I use table 1? It says specific gravity of 0.6, pressure drop 0.3 inches. I got a higher pressure drop. Y'all see that? 4 to 5. So I go to table 2, and they'll allow a half inch pressure drop. So that's why we're on table 2, not 1. Same stuff. They should have said that they wanted us to build out a schedule 40 metallic pipe. Alright, so using the longest length method, if you look at where it says 2, it says, in the appendix, it says the length of pipe from the point of delivery to the most remote outlet A is 60 feet. This is the distance we're going to use. So let me make sure we understand that. Point of delivery, 10, 20, that's 30, 40, 50 to these. Y'all follow me? All right. So for C and D, I got 50 feet. 10, 20, which is 30, 40, 55 to B. 10, 20, which is 30, 40, 55, and 5 is 60 to A. Since we're just doing the longest length, we want to find it. Does that make sense? Now, if we were doing branches, we would look at each one when we go to our chart, our 2.2 table chart, and we would look for that branch at that length. But to be overly conservative, but faster, we're just going to use the most conservative, the longest one. Okay, so with that in mind, I'm going to go to my table, and I'm going to look up 60 feet. Okay, so I find 60 feet in my table. We're on table 402, 42, way back in the tables. I wish I had a page, but I don't. Anybody got a page on the table?
36.
And we just chose this table because that's what they use. In real life, we could have chose what we wanted. Everybody there? All right. What is my requirement for outlet A? 35,000 BTUs, right? Or at 1,000, 1,000 BTUs per cubic foot. This chart's going to be in cubic feet. If we had gas in our area that was worth, say, 1,100, we've got a little better gas than what this is based on. If it was only 900 BTUs, we're going to need a little bit more. Does that make sense? This table is pretty much based on 1,000 BTUs per cubic foot. Okay? And so the outlet needs 35,000 BTUs. So at 1,000 BTUs per foot, I need 35 cubic foot. I'm going to look under the 60 foot, right? What size will cover 35 cubic feet? Half inch, right? 65 is well above 35, right? The very first number, y'all see that? And so that section, A, only needs, what, a half inch? What about my B? It requires 75. Now, if we use the branch method, we wouldn't use 60 feet again, would we? We'd go with its actual length. But we're going to go with the longest length to be quicker. It's not much difference here, but if we've got 50 outlets, it's a lot quicker. So look up under 60 feet. When can we surpass 75 cubic feet?
3/4.
3/4? Okay. Now, one thing's for sure, we're never going to go smaller, right? We're not going to go big and then get smaller toward the end, okay? Now, how many, section 1 carries both of these outlets, y'all? Doesn't it? The only way the gas can get to here is to go through here. And so section 1 carries 110,000, right? How big a pipe do I need for 110 at 60 feet? 3/4 still handle me? All right, let's shoot out here. This is shorter, 50 feet, but we're still going to use the longest length, right? 60 feet. So for 35, what did we say? But I don't have any definition of how length that is. They're just saying it's on this outlet. So I'm not going to size 35, and I don't know how long this distance is, so I'm not going to size it. I'm going to size them together. Does that make sense? If they had said 5 feet or something, I'd individually size it. But on my drawing, there is no footage there. So for 135, what size do I need? You can still get by with 3/4 up here? All right, now I've got to deal with section 3. From here to here has to tote everything to 45. So I'm going to look on my 60-foot level, but I got to handle 245. It's that simple, y'all. Now, what you do is say you had a house, if you're the master gas fitter here, and you go, well, I got appliance here and here and here and whatever, and where are they delivering? Here. And you would just kind of eyeball what you needed. And like I said, I would be conservative. If the whole house from this corner to this one is 50, I'm going to go, I'm going to go 60 because I may have to go around a footing or something. Okay? Y'all see how this works in real life? It's not hard. The hardest part is finding the right table. What am I using for my material? That's it. It's the gas truck. Fuel gas truck. Any questions?